In this video, we're going to finish number 2 from our in-class gift 4-4 from yesterday, as well as go over AP page 246, number 78 that I assigned yesterday. So if you didn't yet do that problem, make sure you do it and then watch the video. All right, so this is the graph we set up when we got started on this problem yesterday. And the idea here is we want to find the largest area. So our goal is to maximize the area. So the way I have this set up is that we know that our base is on the x-axis. So if we counted x units to the right, we also want to count the same units to the left there. So we're going to set up an expression for the base would just be 2x. The height is y, which is 9 minus x squared. So whatever y value is here, that's just going to be 9 minus x squared. So then our area function is just base times height. So it's 2x times the quantity 9 minus x squared. And we could distribute this to expand it, so we'll get 18x minus 2x cubed. So what we want to do now is just figure out the derivative, which will give us 18 minus 6x squared. And we just want to know it's never going to be undefined, so we don't have to worry about that in this problem. So we'll just say, where is it going to equal 0? So we'll set this equal to 0. Solve for x. We'll add 6x squared to each side, divide by 6, we'll get 3 is equal to x squared. Now when we go to take the square root, we don't have to worry about the negative answer, because in this problem that negative answer won't make sense, so we'll just say x is equal to radical 3. We still want to justify that we're going to have a max value at this x value here, so we're still going to make a number line. Notice how I labeled it a prime of x. We're going to have radical 3. So let's say, and I'm substituting this right in here, let's say I just substitute in a 0. So 18, that'll just be 18 minus 0 is going to be positive. And let's say I just substitute in a 10. That's definitely going to be negative. So we know our area is going to be increasing until we reach x equals radical 3, then it'll be decreasing afterwards. So that guarantees that we have a max at x equals radical 3. Therefore, we have a max at x equals radical 3. So now that allows us to finish. We would say our base would then be 2x, so 2 radical 3 units, and our height is 9 minus x squared, so 9 minus radical 3 squared would be 9 minus 3, so that would give us 6 units. So then to answer this, we would say the max area is, if I multiplied base times height, 2 radical 3 times 6, so we would get 12 radical 3. This is where we're going to label. So the max area is 2 radical 3 units when the base is 2 radical 3 units and the height is 6 units. So that's how we go through that problem. All right, let's take a look. And we need our calculators. Since it says the graphing calculator is allowed, we're going to rely, and it's going to be super easy to use the graphing calculator on this. So it says the first derivative of the function is given right here for all x values between 0 and 2. On what intervals is f increasing? So all you have to do is go to your calculator, and we want to graph this function. So all you have to do is type this in. Make sure you're in radian mode, though. So just graph y equals sine of x cubed minus x. And then set the window settings. So go to menu 4.1. Set the window settings to just 0 to 2. So make your x min 0, your x max 2. So you should get a graph that looks something like this. Actually, let me go back and change that a little bit. It should come right down through there again. And then start to come back up here. So the question is, on what intervals is f increasing? So remember, this is the derivative. So we know our derivative is negative here, positive here, and then negative again. So f is increasing when f prime of x is positive. So that's going to happen between 1, if you can't tell by looking, let's go into menu 6. Let's find the zeros. Let's actually find these. So if you go into menu 6.1 and just go to your lower bound, just make your lower bound just to the left of this value and then your upper bound just to the right, and it should give you an ordered pair of 1, 0. Then do the same thing here, go to menu 6.1 and just go to the left of this x value right here and then just to the right of it. And this should give you an x value of 1.69063. So f is increasing when our derivative is greater than 0, and that happens between 1 and 1.691. So that was B.